sou Cristiane Derani, professora do programa de pós-graduação em Direito e líder do subprojeto Água, Energia e Alimento, Sustentabilidade na Comunidade Internacional, que juntamente com os programas de Contabilidade, Recursos Genéticos e Vegetais, Interdisciplinar e Ciências Humanas, integramos a área temática de sustentabilidade dentro do grande projeto institucional de internacionalização CAPES UFSC. Nosso trabalho tem sido desenvolvido com nossos parceiros na Austrália, Estados Unidos, Canadá, Noruega, Inglaterra, Itália, França e Bélgica, grandes universidades com as quais temos trabalhado e construído projetos com nossos discentes, doutorandos, com nossos docentes, trazendo professores para ministrar cursos, frequentar nossos laboratórios e levando também nossos professores para o estágio no exterior e construindo, então, parcerias que pretendem ser duradouras. E assim tem sido. Nosso projeto se orgulha de ter trazido um parceiro da Universidade de Cambridge, que não só está trabalhando conosco, como também desenvolveu agora, recentemente, o projeto com o programa de pós-graduação em energia sustentável em Araranguá.
This sub-project, Research and Innovation for Smart and Environmentally Sustainable Cities, Water, Waste and Renewable Energy of the Institutional Program for Internationalization held by the Federal University of Santa Catarina. The theme for Sustainability is coordinated by the Postgraduation Program of Environmental Engineering. This sub-project is currently coordinated by Professor Rejane Helena Ribeiro da Costa. Professor Maria Elisa Nagel Hassemer is the current post-graduation program coordinator. Also, the sub-project has the participation of other post-graduation programs from this university. In addition, international collaboration with 22 higher education and research institutions in Europe, North America, Australia and New Zealand are included in this institutional network, which aims the improvement of scientific and technological development, including the environmental sustainability concept in sanitation and in the management of natural resources with this international institutional network. The project highlights 3 axes of actions for cooperation with teams from foreign partner institutions, with a focus on research for sustainable and smart cities. Each axis includes specific research activities to be developed by this institutional network. The first axis includes research initiatives for urban hydraulics, water resource management and treatment. The second axis of actions include research and management, treatment and reuse of urban effluents. And the third axis includes several activities in management, recycling and energy valorization of solid urban waste. Finally, in a transversely and in an interdisciplinary way, these activities comprise decision support systems, environmental performance indicators, as well as the contribution of elements of environmental law, design, history, and environmental sociology. All these coordinated research activities have been resulting in high-impact scientific publications produced in cooperation between this university and the international partners.
Hello, my name is Leila Hayashi and I am coordinator of the PRINT sub-project Sustainable Food Production in the field of agrarian science. The sub-project has the participation of 3 graduate programs of excellence: aquaculture, food science and plant genetic resource, and the collaboration of the graduate program of agroecosystems. Our goal is to discuss and develop, together with renewed international institutions, the production of healthy food considering environmental sustainability within the agrarian science. Among our partners, there are 7 priority universities, in addition to other partners of the Print CAPES projects. These include Dalhousie University, University of New Brunswick, University of British Columbia in Canada, Wageningen University and Research in Netherlands, University of Vermont in the United States, Institute of Agri-Food and Technology in Spain, and Potosí Institute for Scientific and Technological Research in Mexico. For the first time, our graduate programs are joining together in the major institutional objective of internationalization, in a joint effort to strengthen programs within the agrarian science. More than research, the focus of the project is the international insertion of graduate programs and the creation of a solid base for future projects with national and international collaboration.
It's a bit lazy today. Good morning, everybody. É muito bom dia, portanto. É muito bom estar aqui, abrindo essa mesa, junto com muitos colegas do programa CAPES Print, do programa institucional CAPES Print. Então, nós temos aqui um desafio hoje de tentar conduzir um processo de apresentação que contemple a todos os programas, né, junto com a professora Rejane, professora Leila Hayashi e muitos outros professores. Vamos estar apresentando um pouquinho de cada subprojeto, de tal forma que, num desafio, né, de tentar falar tudo isso em tão pouco tempo, nós vamos fazer agora uma breve apresentação do que é o nosso projeto na língua inglesa. Leila, Rejane, vocês querem dizer algumas palavras já assim nessa abertura?
Bom dia a todos, é um prazer estar moderando essa mesa junto com o Paulo Horta. Eu já passo imediatamente a palavra para a professora Rejane, que é a coordenadora do subprojeto Pesquisa e Inovação para Cidades Inteligentes e Ambientalmente Sustentáveis, Águas, Resíduos e Energia, para ela introduzir então a convidada desse subprojeto. A palavra está contigo, professora.
Bom dia a todos, é um prazer estar participando dessa mesa, com os nossos convidados e os colegas. Então, tenho hoje que apresentar aqui a professora Aurora Delgado, que é do Conselho Científico de Madrid. Então, a professora Aurora, ela tem colaborado conosco nesse projeto Print UFSC e, gentilmente, né, se ofereceu para apresentar alguns resultados das pesquisas que tem efetuado junto com professores do programa de pós-graduação em Engenharia Ambiental. Então, professora Aurora, please, you can start your presentation. Thank you.
Pinho, eu acho que a Aurora precisamos passar a apresentação, a função de apresentação para ela. Good morning, Professor Aurora. Your microphone is off, please. In the bottom of the screen, in the left side. You get it? I can't listen to you yet. Sorry. No.
I think her microphone is on, but there is some problem. I am not sure.
Maybe the connection, or we need to restart again.
Yeah. Professor Aurora, if you could maybe log out.
You can hear me now.
Sí.
Yes.
The problem is the headphone.
Okay.
No worries, no worries.
Welcome, Professor Aurora. Thank you
You're
for
welcome, really very welcome to this round table, virtual one.
Alexandre, I think,
a função de apresentação para a Aurora?
Ok. Já está.
okay.
It's okay?
That's okay.
Yeah, now it's okay. You can share your screen.
Can you see my presentation?
Not yet.
Not yet?
So I think it's together with the camera symbol. There is another one, and you can share the.
A moment, please. I think now.
I think it's coming. Oh.
Yes. Can you see
Great.
now?
Yes. Perfect. Thank you.
Okay. One moment. Now it's okay.
Now it's okay.
Okay, thank you. Good morning again. My name is Aurora López Delgado, and I am a researcher of the National Center for Metallurgical Research, belonging to the Spanish Scientific Research Council in Madrid, Spain. First of all, I would like to thank CAPES for inviting me to participate in this event. I am going to give you a general vision about the scientific collaboration between my research group and a Brazilian group from the Federal University of Santa Catarina. My research group, named Materials and Energy for a Sustainable Development, established a collaboration in the frame of the Print CAPES project within the graduate program on environmental engineering, specifically with Dr. María Ángeles Lobo and the team of Water Reuse Laboratory, LARA. Our research was focused in the synthesis of zeolite from an aluminum waste and its applicability for the treatment of wastewater. In general, zeolite were prepared by the Spanish group and the water treatment were carried out by the Brazilian group. Here, we can see the web page of my institution reflecting the visit of Professor María Ángeles Lobo and Flavio Lapoli, the coordinator of Water Reuse Laboratory, during their stay in our laboratories past 2019. In a short introduction, the principal research line of my group aimed with the development of added value material from industrial waste, with the objective of transform waste in raw materials, and the development of clean technology for high temperature processes by using concentrated solar energy, in an intent to feed the global goals of United Nations, such as clean water, sustainable cities, and climate action, among others. Here, I highlighted several of our most recent projects, all of them principally based on the use of waste and solar energy. Our collaboration with LARA is part of this project, zeolite from hazardous waste, used in the treatment of effluent contaminated with endocrine disruptor. This project had two objectives. The first one, to get a complete recovery of a waste from the aluminum industry. This is a very toxic and hazardous waste. This waste presents a heterogeneous composition, and it is highly reactive, especially with water, by generating toxic gases like ammonia and also hydrogen. Usually, this waste is disposed in secure sites because of its negative effects on health and environment. Zeolite, as you know, are three-dimensional and crystalline aluminosilicates with porous structure and high cation exchange capacity. They are widely used as absorbent to remove pollutant from effluents. We designed a process to obtain for the first time zeolite from the aluminum waste, in which other residues were not generated, and also we obtained hydrogen and ammonia as byproducts. Once the first objective was achieved, the second one was to use this zeolite for a process to decontamination of water. In this way, we study the removal of heavy metals such as lead, cadmium, mercury, manganese, also aluminum, iron, and ammonia. The result of this process was excellent and similar to those obtained by using commercial zeolites. The test of elimination of aluminum, iron, and manganese was performed by the Brazilian team. The target of the reuse of water laboratory, LARA, is the application of advanced technologies for the treatment of water and wastewater, viewing the water reuse. In this sense, LARA has developing several types of technology, such as membrane technologies, electrocoagulation, advanced oxidative processes, and absorption of metal ions from different wastewater for the treatment of acid mine drainage. Our collaboration with this laboratory, with this team, was framed in this last line. Concerning the absorption technology, LARA is working since 2008, and a variety of absorbents has been studied, like commercial zeolite, activated carbon, and biopolymers. In the last years, LARA has intensively worked in the treatment of coal acid mine drainage, AMD, and effluent extremely acidity and with high level of sulfates and metallic ion, especially iron, aluminum, and manganese. AMD seriously contaminate the natural water of the Carboniferous basin of the Santa Catarina state. The treatment has been carried out with biomaterials, like wren, crab, and oyster shell, looking for sustainable processes with renewable and low-cost absorbent. Our collaboration was focalized on the treatment of AMD with the LTA zeolite synthesized by my research group from the aluminum waste. The goal consists of transforming coal mine impacted water or natural water contaminated by AMD in adequate non-potable use water. In the first phase, we have carried out a deep study with synthetic water, mimetic of water contaminated to the zeolite, contaminated with AMD. Thus, by statistical factorial design, the optimal treatment condition with respect to zeolite dosage and agitation rate were determined. Isothermal studies show the high absorption capacity of the zeolite to remove the metallic ions with affinity in the order aluminum, manganese, iron. The kinetic study showed that 60 minutes are enough to remove almost quantitatively the contaminants. The result has been recently published in Chemosphere Journal, in which we have outlined the sustainability of the process. A hazardous aluminum waste can be used to produce through a one-step process an eco-friendly zeolite, which is capable of treating effluent contaminated with toxic metal at low zeolite doses and short contact time. This study demonstrates that LTA zeolite has an outstanding property for the use in the contamination of coal AMD. In the second phase of our research collaboration, the objective is treating relatively high volume of real AMD with the zeolite. For this, some challenges has to be overcome, such as to increase the zeolite stability, but its immobilization within a polymer gel matrix, to design a system in continuous flux regime which is most appropriate for the treatment of real wastewater, and also a system to allow replacing the zeolite when it is saturated. Future collaboration between the Brazilian and the Spanish team will also be based on the use of concentrated solar energy. The solar facilities in our center in Madrid consist of the double reflection lens, a Fresnel lens, and also a solar simulator, which can be used in the case of adverse meteorological conditions. Both systems can be provided by different reactors and furnaces according to needs. So, we are planning a new collaboration research line in which a slag with high aluminum content will be obtained by Lara, treating the wastewater by an electrocoagulation process. The slag will be treated in the thermosolar furnace in our center in Spain to obtain an aluminum residue adequate to prepare a new zeolite. Finally, the new zeolite will be applied by Lara in the treatment of the AMD by absorption technology. The synergy between the two research groups will allow closing this loop with high impact on the environment. Thank you very much for your attention, and please take care.
Thanks a lot, Professor Aurora, for your very interesting and wonderful presentation about something that our planet needs. We need water, and clean and pure water. So thank you very much. And we will leave the final of our presentations to all the questions. So I will be waiting for questions, guys. Please bring more questions to Professor Aurora. And now I would like to present my colleague and Professor Paulo Lovato, that will present the results that they had regarding the sub-project of RGV. So, Professor Paulo, the stage is yours.
Thank you, Paulo. My name is Paulo Lovato, and I will present the result of our project, which I will immediately put on the screen. Which is called Characterization, Conservation, and Sustainable Use of Biodiversity. This project has something peculiar, that we have a project with only one postgraduate program. In our proposal, we included two other programs, but due to ad hoc decision by CAPES, those programs were excluded, and we ended up alone. Our project is coordinated by Professor Rubens Nodari, and this year, I will report, we sent 2 students and 2 faculty members abroad. First, our student Edson Carbona Medina, who is supervised by Dr. Nodari and Dr. Joner, went to the Center for Research and Agricultural Genomics in the outskirts of Barcelona, which is a joint institution funded by the Spanish National Research Council, the Catalonia Institute for Agri-Food Research and Technology, where I went to work for a time through another print project, the Autonomous University of Barcelona, where it is located. You see the photograph of the campus here, and the University of Barcelona. And under the supervision of Dr. Manuel Rodriguez, Edson worked on this project on carotenoid seeds of Scobedia parasitizing Iridium 2 plants. Scobedia grandiflora is a plant which is used in traditional cuisine in Colombia, and this plant occurs also in Brazil, and it parasites plants. And what he did he developed a protocol for azafranin extraction, since this plant is used as a food colorant in traditional cuisine, and also he identified and evaluated expression of genes involving the regulation of this carotenoid-related enzymes in Scobedia. What's the relevance of that? The team is looking for mechanisms regulating plant parasitic and mutualistic interaction. The last year, they found out a lot of the regulation between parasite plants and plants which are parasited involve molecular signals important for pathogenic and mutualistic relation in plants. So this is, Edson is back. We are in the stage of manuscript preparation. We intend to keep our collaboration with CRAG since it involves 4 different institutions, including 2 universities. Valdeir Lima, another PhD candidate, went to the Natural Biodiversity Center in Leiden. This is a 200-year-old natural history museum, 200-year-old museum of natural history. They carry out research in different parts of the world, and students from many European universities, not just the University of Leiden, carry out their research there. And Valdeir published a paper already about this neglected plant, Brazilian plant, that its extinction is being accelerated by climate change, but on farm, the conservation through sustainable use he proved that it contributes, sustainable use contributes to the plant conservation. So we plan to bring one of their researchers to next year or the year after that. It depends on the pandemics. Professor Nezel Steiner is one of our junior staff, and she is in Fort Collins, Colorado, at the United States Department of Agriculture. Why did she go there? Because it's one of the big seed banks in the world, and she's developing biotechnology to preserve 3 species, including Brazilian species, and also studying biophysics and physiology of seeds of tropical plants, okay? And she's using different advanced technique along with Dr. Christina Walters. We have now an official agreement between the United States Department of Agriculture and the university, and we plan to have PhD students and professors going there and in some point in time bring one of their researchers to teach or to discuss joint projects here in Florianópolis. And finally, one of our senior researchers, Dr. Miguel Guerra, went in a short-term 2-week mission to Italy to visit this Institute of Bioeconomy supported by the National Research Council of Italy. Why did he go there? Because they have this, Dr. Lombardi's group develops different techniques for plant multiplication, but they also have conservation of plant germplasm. And we are interested in their olive tree germplasm, since olive production is an up-and-coming sector in Brazilian agriculture, especially here in southern Brazil and especially in Santa Catarina highlands. And they are interested in having Acacelogerna feijoa in their plant collection. And our program has been developing the domestication and selection, and we have some variety registered by our program of Acacelogerna feijoa. And also, they have a cooperation with a huge company producing plantlets. And so since we have just only small scale production in our application, that was interesting to see how the cooperation with enterprises is developed in Italy. And finally, they have one thing that's really linked to our program, which is on-farm conservation. They have a program for farmers to conserve local hazelnut varieties in collaboration with the industry. Hence, the advertisement in this on this slide, because that's the way. Since the farmers have an economic incentive to keep the old varieties, we can save those varieties from extinction through sustainable use and integration. So that's, we focus our efforts on this, either on this really advanced scientific problems, like the one with the parasite Scopedia, the parasite plant, or to the application in the field and with farmers to promote conservation in a better knowledge of plant genetic resorption through use and through application. Okay, thank you.
Thanks a lot, Professor Paulo. It was a very clear presentation. Interesting to see that. I didn't know it. We have olive oil production in Santa Catarina. That's great.
It's starting. It's starting.
It's starting. Okay.
Yeah, we need since we have a successful program already adapting plant varieties, grape varieties. For instance, our program, Dr. Nodari sent a student to Germany to a wine and enology institute, and they give him another year of scholarship to develop the techniques, and we'll bring those varieties to have more wine and better olive oil in Santa Catarina.
It's a piece of Europe in the south of Brazil. Great.
Yeah, I think we should also be in the health project, because both are good, very good for our health.
That's it. That's it. Thanks a lot.
So thank you, Professor Lovato. I think we can leave the questions for the end, to the end of the roundtable or this workshop. So next I will present, well, he is here already, Professor Paulo Horta. He's the sub-coordinator of another sub-project of this environmental sustainability team. So the word is yours, Paulo.
Thanks a lot, my friend Leila. And good morning again to everybody. And well, I will present this project that talk about sustainability in the South Atlantic, considering a coastal and marine environment. Our project is a kind of joint program of different graduation programs, including ecology and biotechnology and biosciences. This is what is the formal and bureaucratic group. But since the beginning, we had the participation of a botany, oceanography, and also engineer in material graduation program. So we have really a multidisciplinary group working on this, working on solutions to our main problems. We are facing the ocean decade, a moment that the United Nations are organizing this moment to our planet, think about sustainability and think about and produce solutions to our planet, considering global warming, considering ocean acidification, marine pollution, and all different kinds of necessary reflections about our planet. So our project had the opportunity to send abroad students, colleagues, and to invite to our institutions different researchers from different fields. So we had the opportunity to show us, or at least to present what we have here and how to think about the perspective of sustainability from the South Atlantic, from a perspective of decolonization. What is quite important to bring some some novelties to this field that is a very competitive. Well, we have a lot of people that really are doing very important things around the world, and our partners from England, from France, Spain, Portugal, Italy, and Germany, well, they are joining us in this effort to produce some innovation, in fact. So we had 13 fellowships around it, and our students and colleagues join more efforts to produce a higher demand that now we have all the missions we had abroad, and also some novelties to our group. Well, we invited researchers to come to Brazil. We had the summer school that was really very nice. Kalina Brauco is a postdoc that is helping a lot in our sub-project, something wonderful. Anyway, we had 141% of our fellowships organized or used somehow. So was a very interesting opportunity to produce internationalization. And during this moment, I think that the summer course that we organized last summer, we was lucky a bit before the pandemic start. Well, in the end of January, we had a colleague here, Jason Howe Spencer from Plymouth University, and we spent more or less 1 week on board of our sailing ship Echoes, and we produce very interesting moment to produce science, to improve the formation of our graduation students, and also to reach out and to split this knowledge produced during this 2 weeks, more or less, to the community, to stakeholders, to policymakers. So was really very interesting moment where we are showing that we really have a big problem in our coastline. Eutrophication is the scientific name of that, where we have enrichment of nutrients of our waters, and in the end of this process, the consumption of the oxygen, of the dissolved oxygen, and of course the split of that zones in the floor of different ecosystems we have in coastal line. So we are splitting these problems to the community, publishing letters in journals like Science, or this last one in Frontiers in Marine Science, for example, was quite important because it involved the students, colleagues, professors, and of course stakeholders in this process of production of this knowledge. So what's really very interesting. And one thing that is quite important, we foster the participation of the society, trying to split in the media, in local and regional media, what was happening and the importance of it. So we had a very interesting moment to produce and to stand out the result of the internationalization. And I think the next steps that we are trying to foster, the discussion that we are trying to foster, is the creation of an institute of advanced studies or something related with it to our sustainable group. So thank you very much for your attention, and come Leila, let's see what we have. Okay.
Yes.
Okay. Some videos to present in the end, etc. Okay.
Thank you, Paulo.
So
it was great presentation.
Thanks a lot.
Just waiting. So again, for who is watching us, just leave the questions for the end, and we will answer and organize everything to the discussion. So thank you again, Paulo. Thank you, Alexandre. I just find out my screen.
The next
here.
one is
Me.
okay. I would like to present you my good friend Leila Hayashi, that is on the front of this very important sub-project. So the stage is yours, Leila.
Thank you. Sorry, it was wrong screen. Okay. So good morning, everybody. My name is Leila Hayashi. I am the coordinator of the sub-project Sustainable Food Production within the scope of agrarian science. So this project has the participation of 4 graduate programs in the university: aquaculture, plant genetic resource, food science, and agroecosystems. And the main scope...
Professora Leila, desculpa lhe interromper. Olá. Para a transmissão do YouTube, nós estamos com dificuldade na apresentação. Por favor, clique no botão com sinal de mais e dê propagar layout. Vamos ver se...
Onde é que está o mais, Alexandre?
Na parte inferior à esquerda da área azul, escura.
Da nossa tela. Tá. Ok. E
propagar layout.
Propagar layout.
Senão vai ter que carregar de novo sua apresentação. Porque...
Quer que eu carregue de outra maneira, Alexandre?
Eu acho que nós vamos ter que tentar, porque ali pelo YouTube não apareceu ainda.
Tá, peraí.
Só deixa eu te agradeço.
Mas talvez funcione.
Probleminha técnico.
Funcionou.
Agora carregou.
Você vai ter que carregar de novo.
Tá carregando.
Ok.
Tá, e faz o mesmo do propagar a tela, a layout.
Peraí. Propagar layout. E depois eu venho para... Vocês estão vendo minha tela, gente, da apresentação?
Sim, estamos vendo.
Okay.
Tá tudo certo.
Sim.
Aqui, mas funcionou. Quando você propagou, foi para o YouTube. Tá ótimo. Obrigado, Pinho.
Tá. Obrigado.
Tá bom. Boa atividade.
Peraí, que agora eu tenho que fazer tela cheia aqui de novo, né? Peraí. Enfim, that's it. So, again, so sorry for the technical problems. But again, my name is Leila. I am coordinator of the sub-project Sustainable Food Production within the scope of agrarian science. This project has the participation of 4 graduate programs of the Agrarian Science Center of the university: aquaculture, plant genetic resource, food science, and agroecosystems. And the main scope of this project, of course, is produce sustainable food and avoid the problems related to the environmental impacts. So inside the project, we implement some, we couldn't implement a lot of scholarships, but we implement some of them. One of them was to Cláudia Machado. She is technician of the aquaculture department related to the aquaculture graduate program. And she went for 3 months to University of Queensland in Australia to work and have some training related to the water quality analysis in the biofloc systems. This is a sort of cultivation system in high technology. The second scholarship was to the Professor Paulo Emílio Lovato. He just presented some minutes ago. And he had this fellowship for visiting professor abroad. And he went to the Institute of Agri-Food Research and Technology in Spain, where he works with the tomatoes cultivation and also evaluation of the production systems of truffes. So it was very interesting. This is some pictures of this experiment. We also made some work missions. One of them was to Dalhousie University in Canada.
Leila, excuse me, Leila. Can you share, not share your screen, you propagate again, just because we lost the signal in the YouTube.
Propagate again. Okay. And now?
In the blue signal in the bottom of your screen.
Remember? I already did it, but...
I don't know what is happening. It's not in the YouTube anymore.
Oh my gosh. This is a connection problem
just
or not?
30 seconds, maybe.
Ok,
But
let's...
remember, sinal mais aqui do canto esquerdo, compartilha.
Eu fiz isso. Tô tentando de novo, Estranho. Não é problema de conexão, né? Porque vocês estão me
não
vendo
sei,
aqui, né?
não sei.
Parece que é um problema no compartilhar a tela, mas antes entrou. Teve uma hora que tu deu propagar layout e entrou.
Entrou, funcionou por um tempo e parou.
Quer que eu pare de novo e compartilhe de novo, gente?
Eu acho que é melhor.
Ou se tiver apresentação, em vez de compartilhar a tela, carregar a apresentação.
Tá, vou carregar aqui, melhor. Já está em PDF. Technical problems. Just a second. Gente, travou tudo.
A gente está te ouvindo e te vendo.
Tá. Ele está carregando, parece.
Ele demora um pouquinho, é normal.
Minha apresentação é bem pequenininha, então a gente já faz rapidinho.
Ok, agradeço aí a paciência de todos. Logo, logo estará ok.
Ok, acho que agora foi, né? Não foi?
Precisa esperar um pouquinho, né? Let's wait a bit to see the communication with the YouTube.
Ok, acho que eu tô
Ok, valeu.
aqui, né?
Do it.
Okay.
Muito obrigado.
Imagina, obrigada a vocês. So, okay, we made some work missions to Dalhousie University in the Aquaculture Center and Aquaculture Department, Animal Science and Aquaculture Department, where we also gave a short course of 3 days about the tropical aquaculture together with Federal University of Rio Grande and Instituto Federal Catarinense. We also went to the University of New Brunswick, also in Canada, to start the relationship between the two institutions. And I went to this university with the director of the Agrarian Science Center, Walter, representing all the 4 graduate programs. And finally, we organized last year, in November, I think October, November, we organized the first symposium on integration and internationalization of the Agrarian Science Center UFSC graduate program. So we joined all the 4 programs to make an international event. This have the participation of Dalhousie University and also Universidad Católica de Temuco from Chile. And the good thing of this event is that the language, the official language of this symposium was English. So all the students was request to submit their work and present their work in English to stimulate the internationalization inside the 4 programs. Also, for the first time, we joined together the 4 programs and the postdoc students to organize everything. So this is the final picture of everybody very tired, but happy that we have a well-succeeded symposium. So for now, what is the main challenge that we faced in this first year of PRINT project? Well, one of them is that we couldn't implement PhD scholarships to students. And the main reason is because the test of the language proficiency certification was not free of charge, was not available. Our students live in Florianopolis with only the scholarships, and sometimes they have no money to pay for these tests. Also, the cancellation of the preparation course for the certification also was a huge problem because they couldn't have access to these courses. Another problem that we faced is that the scholarships, like the young scientists and PhDs, a student that is not living in Brazil, is that most of these young scientists, most of these PhDs already is committed to another projects. So it's very difficult to them to leave everything and come back to Brazil and participate of PRINT project. Also, for visiting professors in Brazil, the availability for them is only for short periods, so it's very difficult to bring them to 3 months. And finally, the lack of financial support to run the experiments abroad, because we have a little or few or nothing of financial support for developing the experiments. So we have everything. We have the support for exchange students and professors, but we don't have support to running these experiments. So this is one of the huge problems that we faced. So I think that's it. This is our project. I'm sorry for all the technical problems, and I am open for any questions that you needed. So, Paulo?
I'm trying to turn on my camera. It's a bit lazy, but I think now is just to invite Fabricia and let's do it.
Yes. Okay, let's go, Fabricia.
Olá, bom dia.
Vai, Fabricia.
Minha tela, vou pedir licença a todos, falarei em português.
Sem problemas, Fabricia.
Espero que você não tenha problemas técnicos agora.
Estão vendo a minha tela?
Sim.
Perfeito.
Estou vendo.
Ok.
Só que eu achei, peraí, que no YouTube não foi ainda.
Mas tem 30 segundos de delay, mais ou menos.
Tá. Ok, qualquer coisa a gente avisa, Fabrícia.
Ok. Então, eu vou apresentar para vocês esse subprojeto, que é o Nexus, né? Água, Energia e Alimento, coordenado pela professora Cristiane Terani, e integra aí 5 programas de pós-graduação, Direito, Contabilidade, Recursos Genéticos e Interdisciplinares em Humanidade, e ele tem como objetivos, né, reunir essas competências, sim?
Oi, Fabrícia.
Oi?
Vai ali naquele botãozinho de mais, o mesmo que tu carregou, e dá um propagar o layout.
Opa.
Na verdade, é o mais do lado esquerdo. Isso.
Ok, e tenta propagar o layout.
Eu pedi agora para propagar o layout. Apareceu?
Agora tem que dar
Está carregando, estamos aguardando.
Mas pode ir tocando a apresentação que a gente te avisa.
Ok. Então, essa integração, ela vem com objetivos de discutir a questão da integração desses 3 elementos, sob a ótica de sustentabilidade, mas trazendo aí a contribuição da contabilidade do direito para discutir também o papel das políticas públicas, o papel de discutir processos aí em toda a cadeia produtiva, além dos aspectos específicos aí com sustentabilidade, né? Nesse ano, tiveram aí algumas integrações com universidades da Itália, Estados Unidos, Austrália e... esqueci o país. Já apareceu ou não?
Não, a gente está com problema no YouTube. Por acaso você tem ele em PDF já, né?
Isso, ele está em PDF, mas também tem em PowerPoint, caso
eu acho que você pode fazer o seguinte, descompartilha a apresentação e faz que nem eu, compartilha como, descompartilha agora, aperta naquele mais e coloca carregar a apresentação.
Ok.
E aí depois tem que enviar, na verdade, você escolhe o arquivo e envia.
Tá carregando aqui.
It's raining inside the YouTube. Or somewhere we have leaking. It's leaking somewhere.
O Google tá dando um baile na gente, né? Desde o início desse evento, o Google tá... Ok.
Tá fazendo.
Chegou...
Para garantir, dá um propagar layout. No mesmo botão do carregar.
Tem que propagar também. Ok.
Garante.
Foi?
Deve ter ido. Estamos no tempo do delay. Daqui a pouquinho eu lhe confirmo.
Ok. Continuo ou espero mais um pouco?
Pode, eu acho que... Peraí, que ainda não...
Don't seems that it's not working. Não está funcionando, não, Leila.
Não, né? Não chegou no YouTube ainda, né?
Minha sugestão, Fabrícia, então, tentamos de tudo. Eu acho que é um problema de conexão com o YouTube mesmo. De repente, você, então, focamos, descompartilha a tela, Pinho, dela, puxa a apresentação para você e deixa só a imagem dela. O que vocês acham? E aí, Fabrícia, você só apresenta o conteúdo, né?
Ok. E aí ele vai passando as telas que eu vou falando? Como é que fica? Para poder não ficar desconectado assim?
Não. Daí você vai usando a sua apresentação como um guia aí.
Ok. Então, nós temos aí essa integração entre esses programas, né? E esse ano nós trabalhamos efetivamente com as questões relacionadas à definição de políticas públicas, à definição de processos de acionar contábil e jurídico, né? Além do sustentabilidade, para refletir sobre as questões que estão relacionadas, né, com o caminhar aí dessa preocupação com nexos, ou seja, né, água, energia, alimento integrados, né, e o problema de sustentabilidade, de impactos ambientais decorrentes dessa integração. O que nós consideramos aí que tem uma relevância bastante grande esse processo de internacionalização é justamente poder integrar esses conhecimentos com essas pessoas de outros países que também vêm refletindo sobre a temática, né? Destacamos alguns elementos muito interessantes nesse processo em que CAPES Print tem proporcionado para o Brasil como um todo, especificamente aqui tratando do projeto com a UFSC, essa questão de portas que se abrem, né, uma credibilidade que se mantém, uma parceria para realmente ampliar o conhecimento e trazer discussões teóricas e metodológicas, envolver novos cientistas, envolver futuros cientistas, né? Então, realmente tem sido uma experiência muito relevante. Eu vou destacar aqui algumas atividades que o subprojeto já fez e alguns resultados, né? Na professora Arno Dalri Júnior, do programa de pós-graduação em Direito, foi para a Bélgica e tem essa parceria para refletir justamente essa questão de políticas públicas. A professora Helena Aigos, da Austrália, recebeu a aluna Selma Duque, doutoranda aqui da contabilidade, sobre minha orientação, para refletir também sobre a questão de políticas públicas na ótica de orçamento público e de contabilidade. Na Rutgers, Marcelo Freitas, também doutorando da contabilidade, foi na visão de um dos objetivos desse subprojeto, que é refletir sobre programas computacionais, sobre auditoria contínua, monitoramento contínuo, para justamente auxiliar nos processos decisórios. E eu e o professor Rogério Lunques, também da contabilidade, fomos para a Universidade de Macerata, na Itália, justamente para se unir ao programa de contabilidade e direito e refletir sobre aspectos de processos e políticas públicas para a questão relacionada a essa complexidade, né, da produção de alimentos e a sua integração com água e energia. Já teve alguns resultados de pesquisa publicada nas revistas Sustainability, Resource Conservation and Recycling e Financial Reporting and Accounting. São 3 revistas, 2 específicas na área de sustentabilidade e uma de finanças, e as três pesquisas, elas vêm trazer os primeiros resultados que chamam a atenção, primeiro, para os aspectos gerenciais internos, né, de organizações que têm aí uma grande participação na cadeia produtiva e que tem essa preocupação de reunir os 3 elementos para pensar em desperdício de água, energia e alimento e seus impactos. E aí também o terceiro para se preocupar com as questões relacionadas à definição de políticas públicas, amparo legal, que foi aí na 3ª revista de contabilidade e finanças, né? Também teve uma parceria de fazer conferências na Itália e no Brasil, né, com a participação nossa lá e dos professores italianos aqui, no sentido de não apenas apresentar resultados, mas também discutir com os doutorandos em formação sobre tanto a questão de multidisciplinaridade para processos de pesquisa, quanto para os resultados disso nessa reflexão sobre sustentabilidade e sobre nexos, né? Então, como os resultados preliminares teve esse envolvimento com as instituições e algumas mensagens aí que eu acho que são importantes, né? A contribuição de um projeto da envergadura do PRINT para o Brasil é justamente essa abertura de portas que se abrem, a ampliação de conhecimento, as alianças e as contribuições teóricas e metodológicas que trazem, tanto para o processo de formação de cientistas no Brasil, quanto para a própria contribuição da temática apresentada. Então, são esses resultados preliminares aí dos estudos que fizemos e o testemunho, né, da relevância de um projeto como esse para o nosso país. Eu agradeço a oportunidade.
Obrigada, Fabrícia. A gente pede desculpas por todos esses problemas que está além do alcance nosso. Inclusive, o Diogo e o Alexandre estão tentando aqui resolver o problema, mas não está dando muito certo. Mas obrigada de qualquer maneira.
Murph is working hard this morning. Wakes and working full time. If something bad can happen, it will. But that's it. The next one.
Cláudia.
Yeah.
Cláudia, se você conseguir, em vez de carregar, carregar a apresentação, na verdade, né? PDF, acho que talvez dê mais certo.
Yes, good morning to everybody. I'm loading my presentation. I hope it will work.
Finger crosses. It's working here, but I don't know if it's working in YouTube. Just a second.
what is interesting is our cameras. They are there. So interesting. If my suggestion, if it is not working again, we can turn off our cameras.
It's working.
Okay.
It's working.
Okay. So
let's do it.
Yeah.
Good luck.
So good morning to everybody. I'm going to present our PRINT project, Industrial Sustainability, Treatment, Recovery, and Valorization of Wastes, Clean Technologies, Renewable Sources of Energy, and Use of Biodiversity. This is a multidisciplinary project that is coordinated by the program in chemical engineering of our university, and also counts with the participation of several other graduate programs of our university, as for instance, food science, food engineering, chemistry, and environmental engineering. In terms of scientific objectives, this project involves the development of advanced water and effluent treatment technologies, as for instance, separation by catalytic membranes, advanced oxidations, biological treatments, among others. And also the development of new technologies for using biomass as an energy source by gasification and pyrolysis, and also biodiesel production, and also as renewable raw material for chemical reactions, for instance, for the production of bio-based polymers. And last but not least, it also involves the recovery of bioactive compounds from the residues of the agribusiness using emerging technologies, as for instance, high-pressure fluid extraction, ultrasound-assisted extraction, and enzymatic processes, among others. And in terms of internationalization objectives, to make it short, those can be summarized in terms of this last objective, which is to foster the transformation of the participating graduate programs in high quality, truly international research environment. In terms of international print partners of our project, we count with several partners in the Americas, in Europe, also in Asia, and in Oceania. In terms of result and activities that have been performed up to now in our project, we have conducted 7 work missions abroad, 6 visiting professors from abroad we received here at our university. 3 of those are delayed due to the pandemic, but rescheduled to be performed in the next year. We also received 9 visiting professors from abroad here at our university. 5 of those scheduled for the beginning of the next year. 7 sandwich PhDs abroad.
Claudia, excuse me.
Yes.
Can you propagate again?
Oh, yes, sorry.
Go to the plus sign and then propagate. Should work.
Yep. Should I return or may I go on from here? Is it fine?
I think it's fine, Claudia. We could hear you, but we couldn't see the slides changing. So just go ahead, because I don't know if this is punctual or not.
Okay. Which slide are you seeing now? Those with the number 7 work
You
missions,
just
or
stuck it in the first slide. So
oh,
yeah.
Oh yes. So, very sorry for that. Should I think I could move on from this point, or
yes, but it didn't change. We are still have the problem. The slides didn't change, so
now do they change?
Here,
No.
yes, in the platform, but not in the YouTube. This is strange.
Okay.
Maybe
Okay.
you need to upload everything again, but I don't know, refresh.
I don't know how is the schedule of almost finished. I can upload it again and start from the beginning, or
just go to the, let's go to the discussion after the Professor Jules presentation.
I think so. I think it's better. Yeah.
Yeah. Well, okay. Sorry for the technical issues. These technical issues. As I was presenting, we performed different activities in our print project. 7 work missions abroad, 6 visitors, professors from abroad that we received here in our university. Actually, 3 of those were delayed and were rescheduled for the beginning of the next year. Also 9 visiting professors from abroad here at our university, 5 of them for the beginning of the next year. 7 sandwich PhDs abroad, 3 of those in the next years. 3 postdocs with international experience, and young talent researcher with international experience. And all of those actions resulted in very positive results, as for instance, the very interesting and inspiring lectures and courses ministered by the visiting professors from abroad in our graduate programs, and also the missions of our professors and students abroad, which contributed a lot with the achievement of the main goals, partial goals of our sub-project, which are the consolidation of previous collaborations, as well as the establishment of new collaborations, a new project, both bilateral collaborations as well as in networks. Among those projects, I would like to mention the participation in a Horizon 2020 project. I also would like to mention that due to this project, we now have several courses taught in English in our programs, and not only by the professors that come from abroad, but also by the professors from our programs here at UFSC to help to turn our programs in a really international environment, able to receive more students from abroad. Yeah. We also have increased the percentage of master and doctoral thesis written in English. In fact, in the last year, 50% of the doctoral thesis concluded in the chemical engineering program were written in English. And also, of course, the publication of papers in important journals, as those, some of those presented here. Now, all of this with the participation of our foreign print partners. These papers were all published this year in important journals as Chemical Engineering Journal, Chemosphere, Biomacromolecules, Lebensmittelwissenschaft und Technologie, among several other important journals in the area. Well, and with this, I would like to conclude this presentation and thank you all for your attention. I'm very sorry for the technical problems we had. I hope I could give the message. And I would like now to invite Professor Hugo Soares to introduce our next lecturer.
Thanks a lot, Claudia. Let's see if Hugo can. And well, have we the presentation of Professor Jules? Hi, Professor Hugo. Welcome to this round table.
Thank you. May I introduce him now?
Please do it.
Well, it's hi, Jules. How are you? Yeah, turn
Your
on
microphone.
your microphone.
Yes, here I am.
Well, this great pleasure and honor to introduce my colleague for a long time, Professor Jules van Leer. Professor Jules received his master and PhD from Wageningen University in the Netherlands. And he specialized in anaerobic treatment technology. He's a full professor and chair of the wastewater treatment and environmental engineering and at the Faculty of Civil Engineering and Geoscience, where he's the head of section sanitary engineering, and at the University of Delft. And he also has a position at UNESCO, Institute for Water and Education. Well, he has a long list of publications, books, and presentations in workshops and symposium and congress. And Professor Jules participated on our CAPES Sprint project right from the beginning. And he received the first work mission of our CAPES Sprint project, conducted by me, and received the first CAPES Sprint sandwich PhD student, the engineer Michael Kelbert. Professor Jules, the stage, better to say the screen is yours.
Thank you very much.
You're welcome.
Pede para o professor Daú propagar o layout. Broadcasting layout.
We are having some problems on the YouTube connection. You can go to your left, and there is a plus sign, and you choose propagate the presentation.
Propagate. It's propagate. Not, I don't see propagate. I uploaded the presentation. I just did now. So it is there.
Broadcasting.
Broadcasting.
Broadcast layout.
Yeah.
So it's, I clicked broadcast layout. Is that okay?
Just it. Now we just need to wait a bit. But you can start, Professor, please.
Professor, excuse me, if you could just turn off and turn on again your camera, because we are not in the YouTube, we are not seeing you. And I'm so sorry for that, but we are having problems with YouTube.
I think these problems with YouTube we can fix later, just because we are recording this virtual room. So I think we can fix that later, just because if we introduce the camera of Professor Jules, we can lose the presentation and vice versa, I think. I don't know. But now we don't have the presentation and the image. That's weird. Yeah. So sorry, Professor. Cool. What do you think? Maybe start again?
Should I close the camera and start again?
Yes, please, Professor. Let's try it.
Sorry for that.
Okay.
Just because I'm seeing from my screen the Claudia's presentation yet.
Yeah, me too.
So I now restart. So I do see myself and I see my presentation.
So let's try it. Let's try it.
Okay. Let's hope for the best.
Yeah. Thank you, Professor.
Okay. Now we went just in the new lockdown in the Netherlands. So I'm still at the university. That's the last day that I'm allowed to be at the university, and then we all have to go home again for a lockdown of 5 weeks. nonetheless, I will do my best to give you an insight of the work that we are doing now. This is not because, as Hugo mentioned, I'm heading the section of sanitary engineering and wastewater treatment, and one of the development pathway we are now having is, well, not only treating wastewater for environmental protection, but looking carefully to all the resources in the wastewater, what can be recovered. Now, quite a lot already is at the implementation phase, and I would like to go with you through the developments we have in the Netherlands with respect to domestic sewage treatment and what kind of resources already find a way from a pilot and some in demo and some on commercial. And I will also mention what type of resources we are researching now further in the labs at TU Delft. And let me see, I think the next slide. Yep. So here you see the various, the various resources that are being researched. From wastewater treatment plants, you see a conventional activated sludge plant, as well as a high-rate anaerobic reactor. Well, most of the presentation will be oriented to municipal sewage. That means that we will not discuss that much the industrial anaerobic plants that recover other kind of materials. The focal points we have in the Netherlands is energy, phosphate, bound or reduced ammonium, bioplastics, protein, fiber, sulfur, metals, water, and maybe some other may pop up that I might forget, but you can remind me. The next slide is, well, with domestic sewage treatment, it's a very dilute wastewater, similar characteristics as in Brazil. BOD values are always below 1,000 milligram per liter, most commonly between 400 and 500 milligrams of COD. So a lot of water, very dilute. And it is, of course, very, very difficult, if not possible, to have a resource recovery from such dilute streams. So most of the projects that are envisaging resource recovery are focusing on the concentrated sludge line. And what you see here is a very big domestic sewage treatment plant near Delft. So it's treating the wastewater of 1.5 million people of The Hague City and Delft. And what is schematically laid out is this is a UTQ process of Cape Town University activated sludge plant, which is focusing on biological nutrient removal together with activated sludge. So this plant has a common standards of 20 milligram per liter for BOD, 10 milligrams for N, and 1 milligram for P. We're currently in a transition, and we have to go down with N to 2.2 and to phosphorus to 0.1 milligram per liter. Not now at this moment, that will be too expensive. At the moment, we are targeting N for 5 milligrams per liter and P for 0.35 milligram per liter, but slowly we have to go to more restrictive values. And that means, wait a minute. Oh, there's something with the webcam, but I'm not so sure what happens. Anyway, I will proceed. But at the moment, we can deal with 20 milligram, 10 milligram, and 1 milligram. And we have to go to 5, 2.2, and 0.3, and then to 2.2 and 0.1. Now, that means that the sludge line that we generate from the activated sludge, these are much more concentrated. They are 100 times more concentrated. And that means the energy recovery, nutrients, and plastics, bioplastics, and so on, is mainly targeted on this concentrated sludge line. So I will go a little bit through these all different resources, and some are quite more obvious than other ones. So energy is quite an obvious one, and as you know that activated sludge produces is quite some excess sludge in conventional activated sludge plants. We have to think about 50% of the sludge of the soluble wastewater is turned into sludge, and that is also COD. So by means of sludge digestion, you can recover quite some energy. Yeah? If you consider that 1 kilograms of COD is equivalent to 13.8 megajoules of biochemical energy, or 3.8 kilowatt hour theoretical energy, because you have to convert it still to electricity. Now you can calculate that you in principle can close the balance. Of course, not all the sludge is being degraded, and you have also the electricity of the energy conversion efficiency of a biogas motor, which is 30%, a CHP is up to 40%, and currently we are working also with solid oxide fuel cell, and then you can come up with an energy efficiency of 80 to 85% and maybe 90% of high heat and electricity. So this is all known. So what the water authorities were focusing on, and we're also doing some research on this, is the more efficient energy conversion techniques. Also in our lab, we are studying the application of solid oxide fuel cell. So this is a fuel cell that can be fed with a methane gas, but it can also be fed with ammonium, for instance. And then you have a reforming unit in combination with the fuel cell, where CH4 is split into CO2 and hydrogen, or NH3 is split into nitrogen and hydrogen, and the hydrogen, of course, is then oxidized to water, and that means, and that gives the electric efficiency. Now these fuel cells, they have an electric efficiency of 55%, and 40% of the energy comes free as heat. And with the SOFC, this is 700 degrees, so it's quite useful energy. Then green gas production is upgrading biogas. That means getting rid of the CO2. That can be done with membranes or pressure swing. There's various techniques are being in development also at TU Delft to come with green biogenic methane. But of course, the amount of biogenic methane that does not compensate for the fossil fuel methane gas from soil, so there's a quite gap nonetheless. There's a green incentive to go in that direction, and with some subsidiary funds from the government. Now we try to operate better the sludge digester, better mixing, better feeding. We have some PhD research on that aspect. Treatment of excess sludge is being done. For instance, think about the high pressure, high temperature and CAMBI processes, or alkaline pretreatment, enzymes, etc. At this moment, we are developing plug flow digester systems in which we see very high enzyme conversion rates at very short retention times, preventing the use of external enzymes. And that is also being developed with a commercial company on this. Other groups at TU Delft are focusing on pyrolysis and gasification of the residue after a digester, since not everything can be digested, generally not more than 50%, and the rest may go to gasification or pyrolysis. Now, co-digestion is being envisaged, but co-digestion in the Netherlands is not so popular because we don't have any outlet for excess sludge after the digester, since we are not allowed to use it in agriculture. That means only incineration is possible, and if you then do co-digestion, the incineration cost goes up. But overall, in our country, we have we pay about 200 million euros per year only to get rid of sludge, and we have a population of 17 million people. So this is quite an incentive to research further on excess sludge. Now, and this is interesting to share with you, because we're talking a lot about green gas and then you think about talking about anaerobic digesters. That is my special hobby. I did some visit in Brazil, and I was completely surprised, and this is together with my colleague in Minas Gerais, with Carlos Tinicharo. I was visiting some plants, and this is the plant in Belo Horizonte, Onça, and I noticed there was a production of 22,000 cubic meters of biogas per day with an electric equivalent value of 3 megawatt. So I was very surprised that this was simply flared, because there was no interest at all to recover this and to valorize this amount of biogas for productive use. I was pretty surprised by that. But anyway, maybe that other incentives are in Brazil than in the Netherlands. the thing that went quite far is now commonly is phosphate recovery. Yeah? Phosphate now depletion is envisaged about 80, 90 years from now, so we have to be recycling anyway. And what we see in the full-scale plants is that commercial companies already entering the market recovering phosphate. The most easiest thing to recover the phosphate is by making struvite from phosphate. And struvite, ammonium, magnesium struvite, that can be done also in the sludge liquor. After sludge digestion, you have sludge dewatering, and then the rejection water is a high concentration of phosphorus and a high concentration of ammonium. Now, if you then add a little bit of magnesium, you make struvite. But of course, to recover struvite is one, and that is one important incentive is to not have uncontrolled precipitation of struvite in the sewage treatment plant, because that adds up to the operational cost, but to recover it as a product. Now, but to recover it as a product, it must have value. Now, in the Netherlands, we are drowning in phosphorus, so our fields are oversaturated with phosphorate, so the price of this is pretty low. And then you have to make a product from this struvite that is of interest. And one of the companies that is quite effective is it's not a Dutch company, it's Ostara, Pearl, that's a Canadian country. And Pearl is making these granules, these struvite granules. This reactor is such a kind of a crystallization reactor. It's an upflow reactor where small struvite granules are in fact the core of the growth for new struvite. And you make this struvite granules as it's poured into the hand of this gentleman. Now, the interest business case that we have now in the Netherlands is that Pearl is in fact, they are selling these reactors to the water authorities, and Pearl is guaranteeing that they buy struvite from the water authorities at a price of $200 per ton. So the water authorities, they get from Pearl these $200 per ton of struvite, and Pearl is making artificial fertilizer from it, and they sell it afterwards for $1,000 per ton. So the profit margin for Pearl is 800. Now, our water authorities, they cannot go themselves on the market, but via this lease contract, they are able to get some benefit back from the installation, and after a couple of years, they have a return on their investment. Now, at the universities, we did quite a lot on struvite precipitation, but at the university level, the work on struvite, the scientific work is done now. At the moment, we're focusing on other ways to recover struvite, and then we're thinking more about, for instance, using ferritin to recover orthophosphate for the liquid streams, since orthophosphate has a much higher value intrinsically than struvite. The value of struvite is quite low. Now, for instance, other struvite, this is in Amsterdam, they use the airprax method, and airprax, then you get a combination of bad quality struvite, and the price of this struvite is only 50 to 100 euros per ton. So way less than the nice granules that you saw in the previous graph. Now then, another resource is bound ammonium. And bound ammonium, ammonium itself is not a resource that is very scarce. Of course, ammonium is simply coupled to energy. Ammonium that is made via the Haber-Bosch process, and if you make it via electrolysis like Haber and Bosch did in the early 1900s, the energy is about 100 to 120 megajoule per kilogram N. To get hydrogen from electrolysis, if you get hydrogen from CH4 cracking, then it's much more energy efficient. And the company Yara, which is the biggest ammonium producer now in the Netherlands, they spend about 25 to 30 megajoule per kilogram N to produce ammonium. Now, theoretically, the energy content, the biochemical energy content in ammonium is 21 megajoule per kilogram N. And if you have to remove it via nitrification, denitrification, it costs you up to 56 megajoule per kilogram. And it can be a little bit lower, of course, depending on the type of nitrification, denitrification that you operate. If you use Anamox on the concentrate stream, then it costs you 17 megajoule. Now, at this moment, there are other ways to recover this ammonium, which is an energy-rich compound, by directly reusing it. In the case of manure, this is the case. Other companies, they are working on stripping of ammonium from this concentrate reject water, and then get it, and trap the ammonium in sulfuric acid, producing ammonium sulfate as a fertilizing agent. And there are some researches done to partially oxidize it, so making ammonium nitrate, but that can be very explosive, as we saw in Lebanon several months ago. But ammonium sulfate is more common for that. Other groups, like the groups in Ghent, they are trying to recover this ammonium for the production of proteins. I think that's a bit nuts. You can also buy fresh ammonium for that. Why to recover it from a sewage treatment plant, but okay. Others, and then particularly the work that we did in the Middle East, the effluent is then used for fertile irrigation. Then you directly use ammonium in the fertile irrigation in agriculture. At this moment in our group, we have a couple of PhD students working on the recovery of ammonium via electrodialysis, via bipolar electrodialysis, and then you can concentrate ammonium up to a very high concentration. And with bipolar electrodialysis, you make a basic ammonium stream. Now, and that ammonium has a very high value. Ammonium hydroxide has a very high value. You can also use this as a fuel in a solid oxide fuel cell, as I mentioned. But both outlets, that gives a higher value than burning it in nitrification, denitrification. So that's the research direction we currently have in our group. Then the next one is bioplastics, and bioplastics, there are two ways that have interest. One, bioplastics is based on the production of VFA. If you go back to anaerobic digestion, how that works is the hydrolysis and the fermentation, and then you come into volatile fatty acids. And these volatile fatty acids is the end product of fermentation. Now, if you have methanogenesis afterwards, the VFA is turned into acetate and CO2 hydrogen, and then it's turned into methane, and you have methanogenesis. Now, if you are interested in VFA, you have to stop here. So you make VFA as a product. But VFA is a very soluble product, and the concentrations are relatively low. You talk about maybe up to a gram of VFA. This means to get this VFA out of the liquid, this is unaffordable. So the downstream processes make this route determining whether it's commercial interest, yes or no. Now, one thing to turn this VFA into bioplastics is to couple it to the production of polyhydroxyalkanoates, and that is done with an aerobic bacteria. For instance, in this bacteria, you see here the Plasticidi cumulans acidivorans, and that is work which is done in the group of my colleague, Dr. Robert Klerenbezem and Mark van Loosdrecht, and their group. They're working on this process, in which the bacterium is in a short period of time is loaded with volatile fatty acids, and then a very long period without feeding. And as a response, this bacterium turns the VFA into polyhydroxyalkanoates. And you see this is accumulated as a kind of microbial fat inside. You see these white bubbles inside the cell, microbial fat inside the cell of this bacterium. So, and then you have a separation, of course, of the polyhydroxyalkanoates from the liquid. You solidify, in fact, the VFA by means of the production of polyhydroxyalkanoates in the microbial mass that you then can harvest. So by applying a feast-famine regime, you turn the VFA in a solid mass that can then be recovered. And that is at the moment that is being showcased in several companies, at a paper mill, at a candy, in the organic fraction of miscellated solid waste. But since 2-3 months ago, there's also a demo reactor that is treating sewage sludge in this manner. Now, the production of VFA is easy, but the most difficult part is then to turn it into PHA and the downstream processing to turn it into bioplastics, because that's another complete different research that is required for that. And in downstream processing, what is important is the yield of the plastics, the PHA, the purity, the obtained polymer properties, the chemical consumption, the waste generated, and also the end user specification. What kind of plastics do they want? And are you able to produce that mix of volatile fatty acids that make the proper PHA for giving the proper quality of plastics that they use? And this is a completely different game. So producing VFA is simple, but it's only part of the process. There's another way to produce bioplastic, and that is done in the new, maybe you heard of that, this is the aerobic granular sludge technology that is being developed and implemented worldwide at this moment. And that is sold by the company Royal Haskoning DHV under the name Nereda. In Brazil, you have several of these full-scale reactors in operation now, like in Rio de Janeiro. And it seems that the dry weight of the granules that you produce, that they have 10 up to 20% of these alginate-like, it's not alginate, but it's a polymer that has similar properties than alginate. In October last year, there was a new factory in the Netherlands that is recovering this alginate from this sludge, and they're producing a new polymer from it that is sell on the market. If you Google the name, Kaumera is Kaumera, Kaumera, you will find this company making this polymer from excess sewage sludge. And that, if that pays off, that will be fantastic, because then there is no negative value sludge anymore, but you have a positive value product. And that is of course good news for if you would like to save cost in sewage treatment. Other polymers that are being researched are the proteins and other biopolymers. The first proteins that were researched were the proteins that were made by worms. So there was a kind of a development of making worm reactors. We also had a PhD student working on that, producing worms from the excess sewage sludge. But now, after several years of PhD studies, it became clear that this type of proteins produced on sewage sludge will never, ever enter the food chain. Not as animal pet food, and certainly not the human food chain. So this idea of making proteins in the waterline, forget about it. Will never be a success, because we cannot use these proteins because of legislative restrictions. Now, the only thing that can be done, and that has our colleagues in Spain, they have done that, is to couple algae after the anaerobic reactor, or maybe also after activated sludge, but photosynthesis using algae, turning the CO2 that you make into COD, or into BOD, into organic matter. And that organic matter can be harvested. In the beginning, they thought, okay, these algae, they can make high quality products, but with sewage, that is not possible. Some algae, they can make more fats, so then long-chain fatty acid recovery could be a possibility, and maybe making biofuels from it, like biodiesel. Also, that costs quite some downstream processing, I have to say. But like what they do in Spain now, they simply recover the algae that they have, and they turn it into biogas as well. And afterwards, they upgrade the biogas, separating the CO2 and making compressed natural gas of a bio-based origin. So that is possible with the biopolymers. Let's see what we have more. Fibers. Oh, that is interesting. With fibers, that is maybe a local possibility, because in the Netherlands we produce a lot of toilet paper, about 10 to 14 kilograms of toilet paper per population equivalent per year, and we throw everything in the sewer. Now this reaches the sewage treatment plants, and they will be covered partly in the primary clarifier, or it will go to the aeration tank. Now, some years ago, there was some research done on a Salsons filter, which has a mesh width of 300 millimeters, or 0.3 of 300 micrometers, or 0.3 millimeter, very fine screen, and you can filter these these cellulose fibers out of the sewage sludge. So, and you have these filters up front at the headworks, so prior to the aeration tank. And they have several advantages. The advantages that you have is that you lower, in fact, the COD load to the sewage treatment plant, so that's less energy use, and you can recover the cellulose. And the cellulose of these fine sieves is very easy to dewater. And then you get a very energy very high density energy, high density product. But the paper industry, they didn't want this because of the origin. Well, we don't go ahead, as they say, we don't going to recover toilet paper that don't sell off, and we will not sell any pizza box anymore. So that's a no-go. Paper industry, they don't want this. But in the asphalt, at least in the Netherlands, we use cellulose under the asphalt roads for dewatering. And now there are some trials done with this recovered cellulose. That also works perfect. And that means they avoid the purchase of virgin cellulose from Scandinavia and use the recovered cellulose from the saltness filter. This is a non-food application, and that has wide acceptability. Now, alternatives for this material, you can incinerate it. It has a high energetic value, but you can also digest it or thermophilically digest it, as one of our students did it, PhD students, and turn it into biogas, or you can turn it into VFA for making polyhydroxy alkanoates, as I explained in the previous graph. Then sulfur. Well, sulfur is particularly covered to biogas desulfurization. Now, this is a technology already in full scale since the 90s, with the idea, and the company CAPES in the Netherlands is very active on this, in trying to bring the recovered sulfur, that is obtained from the sulfide from the biogas, partial oxidation to elemental sulfur. And this elemental sulfur you can sell as a fertilizing agent. So they tried for 10 years, more or less, to penetrate the market with this product. But as the director of Parks informed me, that is very, very difficult. They call it 30-pack. This is a natural solution, as they say, containing biosulfur, but the market has some constraints. Since there's an unmatched demand and supply, the biocide and the fertilizer regulations, they have very big hurdles for new products like this 30-pack. And the farmers, they request total solutions, and they don't focus only on sulfur. There are only very specific spots in the world where there's a lack of sulfur. But most of the farmers, they need both sulfur and NP, so an integral solution. And biosulfur is incompatible with the traditional sulfur distribution channels. So biosulfur, yeah, they have different properties, like too much water, it's hydrophilic, you name it. So it's not the same as the sulfur bloom of chemical sulfur. So the idea is there, but the penetration of the market with this product is extremely difficult. Well, metals, not with domestic sewage, but there are specific industries, and then you have to think about acid mine drainage, heavy metal industry, copper mining, gold mining. Then if you then combine sulfate reduction with metal sulfide precipitation, in the Netherlands we have a metal fabric producing zinc, and they recover zinc from their own effluent together with sulfate reduction. So they recover zinc sulfide. And the sulfide is turned back again into sulfuric acid, and the zinc is used as raw ore in the production line. So this is a local cycle closure for zinc that is possible under using these anaerobic reactors. Water is another topic which is, I think, is very much of interest for many parts, of course, in the world. For the Netherlands, we are a water-rich country, but nonetheless, there is interest, even in the Netherlands, to recover water. In the past 2 summers were dry. 2018 was very dry. Several months we didn't have rain, and then the water resources, the subterranean water resources, so the aquifers, they became depleting, and it was, for us, it was quite shocking as a Delta country that suddenly we have a kind of a water crisis in the country. So at the moment we have some industry that are actively recovering water from sewage treatment plants, and here you see two examples, because sewage is a very reliable water source. Always there is water from a household and from the city. It's also a potential water source for agriculture industry. Households, I don't think so, because there's too many constraints with that. But for industry, agriculture, I do think this is possible. And also, if you reclaim water from a sewage effluent, there you have immediately a complete treatment of the effluent, and the entire discussion of micropollutants is intercepted, because you create an absolute barrier also for micropollutants to enter the environment. In this example, you see two examples. On the right examples, you see the water company Evidis. They are getting the water from the town of Terneuzen. This is equipped with a membrane bioreactor, and at a company of Dow Chemicals, this permeates, so the effluent of the wastewater treatment plant is upgraded using reverse osmosis membranes to process water. And for them, it is very cheap, because this Dow Chemicals is not allowed to pump up aquifer, since this company is located near the sea, and if they would pump up the aquifer fresh water, they will salinize the water, the aquifer further, and that is forbidden by the local authorities. So the options for the Dow Chemicals is either to use seawater or urban water. Desalinization of seawater is very expensive. You need reverse osmosis of 50 bars. But desalinization of urban water is only 5 bars. So for them, it is much more cost effective to desalinize the urban water in comparison to the seawater. And that's why this is a very good business case of public-private partnership. And on the left side, you see another public-private partnership. This is the Dutch oil company. They are trying to deplete the residual oil reserves that we have in the Netherlands. This is very thick oil. And you can mobilize the oil only with hot vapor. And for the hot vapor, they need fresh water. But in that zone, this is an ecological sensitive zone. They're not allowed to use surface water to extract surface water from the ecosystem. So the only option what they have is to use the effluent of a wastewater treatment plant. So that effluent produces 30,000 cubic meter per day of effluent, and in the water factory, in the picture below, this water is upgraded to steam, and the steam is used to inject the oil fields for mobilizing the oil. Okay, I think yeah, we almost to the end. I worked quite a lot with anaerobic treatment, and I just would like to share this slide to close. In the anaerobic treatment, we coupled it in our research with agricultural reuse, and we did it in the Middle East. You see some examples in Jordan, in Yemen, and in Egypt, where an anaerobic pre-treatment reactor was used to treat the sewage, concentrated sewage, of 1,500 milligrams of COD per liter. And the pre-treatment was followed by post-treatment, and then come up to the irrigation quality. And the anaerobic reactor that served as a scavenger of the solids, because in Jordan they used a lot of drip irrigation, and that needs to be solids free. So after the anaerobic reactor, you have a post-treatment, and then you have a filter system to prevent that the solids clog the irrigation system. You have the mineralization of organic matter, so only stabilized natural matter reaches the field. Removal of heavy metals from the water line, because you have sulfate being reduced, and the sludge is then the heavy metals with the sulfide will precipitate, like zinc and nickel and copper, and that will go to the sludge line. The sludge will partly filter the helminth eggs. The nutrients will be provided, since under anaerobic conditions ammonium and orthophosphate will be produced that are used for fertilizers. You produce a stabilized soil conditioner. If it's too not heavy metals, farmers may use it, but not everywhere. And you produce them some energy for the post-treatment or for irrigation pumps or whatsoever. So in that case, the anaerobic reactor has quite an interesting role there. I think with these examples, then we come a little bit to the end. So now I discussed several resources that are actively recovered from the wastewater, and quite some of them are in the competitive scale already. So these are commercialized. But what the research learned to all of us that we always have to check the sustainability of a certain compound. If it costs much more to recover something, and more important, if you don't include the valorization chain, so the consumer that has to buy the resource or the downstream processing is not affordable, then it makes no sense to recover a certain resource. So that is so you always have to check the sustainability for a resource before you would like to opt for that research recovery. So in resume, if you go quickly over it, energy for local use, that is stabilized, that is done, that is already in practice and large scale. Research is being done at the university to optimize energy recovery to its highest possibility. Phosphorus, struvite has a low price. Nonetheless, struvite is in the market. Other ways to recover phosphorus, like orthophosphate, is being developed at this moment. Ammonium is linked to energy. So it's not a resource that is depleting, but it's more linked to energy. Bioplastics, they have an intrinsic high value, but don't forget that the downstream processing is quite expensive. It's not just producing VFA, it's only part of the story. Proteins is so far no-go because they cannot enter the food chain. Cellulose for road construction, that seems, at least in the Netherlands, quite interesting application. Sulfur has a good property, but it's a very difficult market to enter. Metals for local solving problems of interest, but to enter a commercial valorization scheme, that is questionable. Water is upcoming, has high interest, and also has high potential. And if you combine water with nutrients, maybe fertile irrigation for agriculture, that could be applied at a larger scale. That was a little bit what I wanted to say. Then, thanks for your attention. Muito obrigado pela sua atenção.
Thanks a lot, Professor Jules. It was a very interesting presentation. Very, very excited to see. I'm very excited to see all these possibilities from Suwatch. So I would like to invite you all to turn on your cameras, and then let's try to decide what we're going to do, because when Murphy is here today and it is working hard to produce a lot of troubles in the communication with the YouTube, so we don't get, in fact, hear your presentation, but it was recorded here and we're gonna upload everything there later. But I think we can start our discussion. So I would like to invite all everybody that wanna come turn on the camera and join us in this round table, and let's start to present to our speakers our questions. I'm suggesting a general question to start a discussion, and mainly, of course, Professor Jules, and I don't know if she is with us, Professora Aurea.
Professor Hugo
Professor Hugo, Professora Regiane, and of course, everybody that want to speak on English, let's, of course, speak on English, but if some of you would like to speak in Portuguese, we can try to decolonize a bit this discussion, and let's try to, I'm seeing that Professor Jules can speak a bit of Portuguese too. So,
yo puedo hablar en español.
Wow,
but
should we wait a bit? Just please,
a second.
Tell us.
Yeah, Alexandre and Diogo
they are trying to restabilize the communication.
And I think YouTube is answer. Podemos continuar, Alexandre? Okay, let's start. Okay.
Yeah,
okay.
It's working now. Great.
It's working. Okay, perfect. Sorry for that, everybody.
Fine.
Okay. Paulo, well, I can read the first question from Professor Nodari, maybe?
Please do it.
Okay. So, Professor Jules, comparative to sustainable agriculture systems, organic and agroecologic, in which there is a nutrient recycling, the industrial production ammonium or phosphorus with demand more energy.
Yeah. Well, Professor Nodari is just asking if the industrial production of ammonia and phosphorus demand more energy. Comparing with the agricultural, I would like to present an additional question regarding this question, just because we have a kind of wetland treatment, wetland using the natural capability of plants to absorb nutrients. Comparing these two different possibilities, the costs and the benefits of each one. What is your opinion, Professor Jules?
Yeah, well, of course, the situation in the Netherlands is different. We have quite intensive agriculture, and our agriculture requires artificial fertilizers at a level we have at this moment. We noticing this is not very sustainable what we do. So in fact, what we should do, and that is maybe also the bottom line of this question, that you use the fertilizers that you produce also during agriculture. That means all the residual ammonium and the phosphorate that comes from the manure, from these byproducts, that you recycle them in a natural way back in the agricultural system. Now that is something that is better indeed, because our balances, our N and P balances are completely disrupted in the Netherlands. Don't forget that the Netherlands, we have a country that is so small, even smaller, but we are the second producer of agriculture, second exporter of agricultural goods of the world. First you have the United States, and then you have the Netherlands. This is absurd. And the cost is, this imbalance in nutrient cycles. And that means also the nutrient requirements that we have are much higher than what can be provided by agriculture at this moment.
Okay.
But I like the biological farming a lot, and I think we have to go to that direction to close the balances.
Yeah, just because we have a global concern considering the eutrophication that we observe in aquatic and coastal marine ecosystems. This is what in our project, considering internationalization project and ecology and biotechnology, we are looking for different solutions to provide this balance, this equilibrium of ecological process, and trying to use this like an opportunity to also produce social justice or equitability. And how far so far? Well, if we don't have another questions, I'm presenting you here a broad question that maybe everybody can discuss a bit. How far we are, or are we, to really reduce the impact of seawater pollution or coastal runoff on aquatic and marine ecosystems or environments? Can the planet thrive with the Green New Deal that Europe is presenting? The Green New Deal seems to me an opportunity to foster this kind of multilateral discussion.
Well, that is the idea behind it. So it's you have the European Green Deal, and also in the Netherlands we have a Green Deal. The Netherlands, they adopt without any doubt the European regulations, and that is why we have to go down with phosphorus emissions from sewage treatment plants, which at the moment is 1 milligram P in the effluent. We have to go down to 0.1 milligram P in the effluent, and with ammonium at this moment the laws are 10 milligrams nitrate N per liter in the effluent, and we have to go down to 2.2. That is because we are a densely populated area, and the European Union, they look not anymore to absolute values, but they look to the ecological impact discharge has. This means we are a coastal area with large urban areas directly near the coast. So our effluents, our discharge should not affect the ecosystems that is near to us. And for that reason, we have to treat our sewage much more deeper with respect to nutrients, N and P, than, for instance, an inland country like in Germany or in Czechia, Czech Republic or so on. They can relax more if they don't discharge in ecological sensitive zones. However, also in the inland, like if you have a oligotrophic lake, then you have to respect the ecosystem of that lake, and then you're also not allowed to discharge anymore high concentrations of nutrients. You have to treat very deeply the wastewater. But in principle, I like what I like about this legislation, that you don't have rigid targets for everywhere, but you can relax where it is not needed, but you have to be more stringent where it is needed, and that is the large centers. For instance, in your case, the coastal zone of Rio de Janeiro or Sao Paulo, in that area, the efflux is so high on the ecosystems, that will impact, and it has to drop down in order to preserve the natural environment.
Thanks a lot, Professor. Claudia.
Yeah. Yes, thank you very much, Professor Jules, for your very, very interesting presentations, showing us the broad spectrum of technological and scientific issues involved, and also the importance, of course, of the valorization chain, which is essential in order to turn it into a more circular process or way related to the wastewater. I would like to comment you about the valorization of the chain, of the product chain. Do you believe that this is the point that still presents the main challenges, or?
A very good question. I like because that was for long times it was not well taken into account. How you can drive sustainability with idealism, and you can ask for governments to support by subsidies, but this is all very fragile incentives, and politics. And in Brazil, you know much better than we do in the Netherlands. Is a thing that can go any direction, and sometimes in a complete wrong direction. So, but in the end, a product needs to find the market. A product needs to find its way for closing the cycle. So there should be a company that should be interested in a product that you make, and only then the supply chain is an open chain, so that you can produce your compound. And that means also in the search for making a specific compound, don't do that alone as a scientist, but look into the market and what is required. and find the companies that in principle are interested and discuss with them in what form they need a certain resource. And in that way, you need, it's a kind of a joint operation. So on one hand, you have the scientists, and I know that in Brazil, there's a bigger gap between scientists and industry. And in the Netherlands, we more cooperate with each other in order to, and then you have also possibility to close that gap. Because if you make a product and nobody is interested, it will never be implemented. I had this discussion with some colleagues in Brazil. They said, okay, we're now going to make hydrogen gas instead of methane gas in an anaerobic reactor. And I say, why? There is nobody interested in that. Why would you do that? And at the size that you can make that, the size is so small, you're not going to carry a little bit of hydrogen from one side to another side. If this is not embedded into an infrastructure, it will never occur. And yeah, we as a scientist, we sometimes intend to forget that. It's that particularly in our field, in the environmental field, recovery, recycling, we deal with one part in a technology intervention and developing the proper recovering technology, but then it has to go into the chain.
Yes, thank you very much. Yeah.
Most welcome.
Paulo, I would like to invite Professor Maria Angelis as well. She's representing Professor Aurora, and because she also talked about the zeolites and the sewage treatment. And I have a question for both of them, Maria Angelis or Professor Jules. One thing, so this is very delicate because of course, we scientists, we work a lot in the investigation of sustainability, but the thing is how transform this in a political service or a public service. And because this is very difficult, we have all the results and we know what is working and what is not, but the difficulty as well is to give this return to the society. So what do you think about that? What is your experience about that, Professor Maria Angelis and Jules?
Maybe first, women first, Maria Angela.
Bom dia a todos. Eu não sei se vocês preferem que eu fale português ou espanhol.
Podemos falar espanhol, porque professor Jules habla español también.
Parece que pregunta. Yo voy a responder en español. Bueno, yo llevo aquí muchos años trabajando en Brasil, hace 10 años que soy profesora de la Universidad Federal de Santa Catarina, pero soy española, entonces voy a hablar en español. Con respecto a tu pregunta, yo no sé si las políticas públicas están todavía, están ya pensando en recuperación, en reciclaje, en economía circular. Pero desde luego la sociedad sí, y la ciencia mucho más todavía. Entonces, creo que es una cuestión de tiempo, pero ya sabemos que los recursos son finitos, los recursos se acaban y tenemos que aprovechar lo que tenemos. Entonces, me parece que todos estamos trabajando en esa línea de intentar aprovechar todo, de acabar con el desperdicio, en fin, de recuperar, de reciclar, de aprovechar, y me parece que, en fin, eso es una forma de hacer las cosas que requiere de mucha tecnología y de mucha ciencia, pero creo que estamos en el camino, ¿no? Siempre las políticas van por detrás de los avances, ¿no? Pero creo que llegaremos, sí, porque será la única solución. No sé si he respondido a tu pregunta.
Claro. Professor Jules?
Yeah, in fact, we had the same situation, but it was maybe 10, 15 years ago. For instance, with the struvite, that was seen as a waste product. But there was a public opinion that okay, we have to do something on the future with struvite. And in fact, the technology was there. We knew how to recover struvite, but it was politically was not allowed. But then there was such a pressure on the politicians, and then the law was amended, and now struvite, depending on the level of heavy metals that is associated with the struvite, is allowed to use as an alternative fertilizer in agriculture. This means the scientists, you have explorative research of scientists that can be anything, so it's fine. Then you have directed research of engineer scientists towards a technical solution. And then you have engineers that are discussing with the end user in what type of form do you would like to have this research to come to a good product to be made. And then you have to convince the authorities for amending the legislation that you allow to use it. Of course, and we are a very small country, so the negotiation lines are very small, distances are small, and in our case, we have, it took not that long before the law could be amended, and now there's an incentive from the government to actually force a Green Deal. Now we have subsidiary programs that are subsidize research in this Green Deal, in which water authorities, together with universities, they can get funds when they look for solutions for closing cycles, for instance, in the water line with domestic sewage treatment.
I think the public opinion is giving a pressure because now I realize that my students have more conscience than myself when I was in that age about the environment and recycling, all this idea. So I think this kind of pressure also can help to drive our research and also the political situation. Brazil is not in the perfect situation right now, but I think the social movement can help on this. I agree with both of you, indeed.
But you see, I think the moment right now is really very delicate. And sustainability is not one option. I think we need, change how loud we are transmitting this message. Just because we are really losing species, environments, and very fast. And the tipping point, we know it is close, so we need change. And I don't know if the policymakers we have and stakeholders can really realize how fast the change can be and how deep they will change our way of life. But I would like to bring Wanderlei Rogério Moreira Leite question. Hi, Jules. Thanks for your talk. Producing bioplastic from microorganisms is definitely a very brilliant way to convert residues into added value products. In your opinion, how can we go further on this topic in order to improve the originality of new research proposals? Thank you.
At this moment, this is coming to a stage of a demonstration scale. So a water authority in the west side of the Netherlands, they now acidify the sludge, so they have an acid fermentation process coupled to the recovery of volatile fatty acids and turn it to polyhydroxyalkanoates in an aerobic process using this type of bacteria, turning into bioplastic. So there's a chain at this moment to be generated in which also a bioplastic producer is involved. And I'm sure on the biology there was always some new research to be created. For instance, some bioplastics they need to have a guaranteed specification. Think about the hardness or the stiffness of a plastic, and that is determined by the ratio of odd-numbered versus even-numbered volatile fatty acids. That's the chain length, the propionate, the butyrate, the valerate. So the ratio between valerate and butyrate and the ratio between valerate and acetate, that gives the product quality of the plastics. And that is what we know now from the plastic producers. And now we go back to the biology again. How now can we guarantee that we produce valerate and propionate and not butyrate and acetate? So now this kind of research is now being done. We also have a PhD now working on that. How can we now guarantee that the biology make what we need later on because that is giving the right type of plastics that the end consumer wants. Now, and in this interplay, there's a whole lot of research.
Thank you, Professor Jules.
Yes. A last question here. We are running over the time, but I have Thales Abreu saying about Brazil, wherein the government believes that the resources are not finite. What is the international perspective to see starting to work with our waste as a renewable resource? Are there an expectative? And I think Cristiane, our prorector, she is working in this field. She can answer us. Cristiane, welcome.
Hi, everyone. Thank you for giving me this chance to answer this question. I was following the presentation all the time, and I really was very keen to participate. I am the leader of the water, energy, and food project. Also I'd like to have a chance to pick the opportunity to answer it. And since I work on governance and law and politics, I think this question could be also answered. So I could try to answer this question, because yeah, we need politics, we need policies, we need policy, we need politics, and we need policies. And I think we are very weak in this, in both nowadays. But we are building this with the social movement and the strength of our universities and our institution, democratic institution. We can push to this opportunity, because also we are part of an international community, and the international community is working very hard to substitute plastic and to find a way for a better circular economy. The international organisms, they are very conscious about that. And I think as far as we, as intellectuals, as scientists, go on the international forum and speak out about these technologies and the commercial possibilities and also political possibilities to enforce it, I think there is a way. If we work with social movement and scientists and intellectuals on the forum of international organization, and wait for better sensibility of our leaders, which I think it's going to come very soon, because you know, we learn how to swim when the water goes high. So it's time now to do this. But it's very important for scientists to speak a lot about their conquests, their development in sciences, because people don't know about this development. They just think, well, what we are going to do if we take off plastic of our lives. So there are alternatives, and we have to tell them that there's an alternative exists, and they exist because of the universities. This is very important. And with this answer, I'd like to finish this fantastic roundtable. Thank very much our guests and our scholars here from UFSC. I'm very proud to take part of this thematic, and also to at this time be the leader of this Print CAPES UFSC, that I have myself the opportunity to know better throughout these 2 days of hard work and marvelous presentation. Now to finish with a gold presentation, we are going to show the video produced by Paulo Antunes Horta. Thank you very much for everyone.
Thank you.
Thank you.
Thank
Welcome.
you, guys. Thank you, Professor Jules, Maria Angelis, everybody. It was a very
welcome.
morning.
Pleasure.
Nice to meet you.
Hi, the CAPES Print Ecobiotech Internationalization Project of the Universidade Federal de Santa Catarina, with the graduation programs in ecology, biotechnology and oceanography, provides opportunities as the last Floripa summer school. A school on board of our sailing oceanographic ship, our ECO. We are intensifying the international academic interactions, promoting lectures, workshops, and meetings. With a multidisciplinary approach, we are fostering a broad discussion about the role of marine ecology and related applied sciences in the context of climate change, ocean acidification, warming, and pollution. Our project helps develop the abilities and knowledge to identify these environmental problems, their causes and consequences. With this strong basis, we are discussing and presenting solutions to stakeholders, a healthy ocean and society. The first 2 years of our project, with the CAPES Print financial support, we visit partners and institutions. With the exchange of experiences and infrastructure, the viability of 5 PhD sandwiches, with the Brazilian presence abroad, and the attraction of visiting professors to our institution, we are improving the formation of our students, researchers, and the quality of our works, providing contributions to consolidate the internationalization of Brazilian science, building innovation in nature-based solutions to the sustainable development. Come with us to create innovative solutions to our future with this transnational, broad, necessary, and wonderful experience.